Okay, Iobowan, welcome you all for today's video. Today I am going to do another important experiment, which is determination of copper in copper sulfate solution using iodometric titration. Okay, here we will do a titration to find out. Here I have a copper solution, copper 2 plus solution. I don't know the concentration of this copper solution. However, I will do a titration with sodium thiosulfate. Actually, the copper sulfate is not react with sodium thiosulfate. Here we are doing a very interesting thing, which is that we will use potassium iodide solution and we will mix potassium iodide solution with copper solution. At that time, copper will reduce into Cu plus and I minus will oxidize into I2. So I2 gas will trap in the solution with excess potassium iodide as I3 minus. This I3 minus will react with sodium thiosulfate. By using the sodium thiosulfate amount, we can back calculate the copper concentration in our solution. So this is very interesting thing. So I will explain that in the green board. Let's go to the green board. Okay, what's going on here? The basic sketch is this. Here we have a burette. Burette is filled with sodium thiosulfate, Na2S2O3 sodium thiosulfate. In our titration flask, we will add 10 milliliters of, your desired volume doesn't matter, desired volume of copper sulfate or copper 2 plus solution, 10 milliliters. To this solution, we will add 5 milliliters of potassium iodide solution. So both potassium iodide and copper 2 plus solution are in this our titration flask. So what will happen? So just after mixing both copper solution and potassium iodide solution, what will happen? The copper Cu2 plus will reduce into Cu plus. Okay, the oxidation number of copper is here 2, here plus 1. So to balance the charges, the minimum positive value is here, this plus 1, here plus 2, we have to add 1 electron, okay, to this side. Now oxidation number will also, here charge will balance, positive charge is balanced by this electron, and here there are 2 positive charges and here electron is 1 positive charge in left side and here. Now this equation is balanced. Okay, after that we have potassium iodide. So important ion is I minus. When copper 2 plus reduce into copper plus or Q plus, this I minus iodide ions will oxidize into I2. Here negative 1 oxidation number, here 0. So the least number is negative 1. So we have to add. So another important thing, we have to balance the number of atoms. Here 2 iodine atoms, here we have to use 2. So now here this negative charge should multiply by 2. So now it is minus 2. So we have to add 2 electrons for this side. Now charges are balanced. Okay, here 2 negative charges, here 2 electrons. Now charges are balanced. However, in this equation we have 1 electron. This is our first equation, this is our second equation. Okay, now the thing is, when we mix potassium iodide and copper 2 plus, these reactions are happening. Okay, what is the balance reaction? I will write down the balance reaction above. Okay, here to balance, the number of electrons should be equal in both the equations. Here number of electrons are 2, here 1. So we have to multiply this first equation by 2. Okay, now we can write down the balance equation. So 2 Cu2 plus 2 I minus will give us 2 Q plus I2. Okay, that's the balance equation. Now this copper ions will reduced and I minus will oxidize. So now we are doing titration with sodium thiosulfate. Sodium thiosulfate will react with this iodine. Okay, now you know this I2 is a gas. Gas will evaporate. Here we are using excess amount of potassium iodide. When we use excess amount of potassium iodide, this liberated I2 will trap with those excess I minus and will convert into I3 minus aqueous. So we trap liberated iodine by using excess amount of I minus. Now this I3 minus in the solution, we will titrate this I3 minus, that means this I2 by sodium thiosulfate. Okay, so now sodium thiosulfate, here S2O3 2 minus plus this I2. Okay, when I2 react, this thiosulfate ions will convert into S4 O6 2 minus. Okay, I2 will convert into I minus again. Okay, here we have to balance the equation. Here we have to put 2 because there are 4 sulfur ions, sulfur atoms here. Okay, now we have to put 2. So molar ratio of or stoichiometry of I2 to thiosulfate is 2:1. So we know the concentration of sodium thiosulfate. By using that, we will read the volume of sodium thiosulfate with the titration that from the scale of the burette. So we know the concentration of thiosulfate and we know the volume, we can read it by this burette. So we will get the number of moles of sodium thiosulfate. The iodine gas number of moles will be equal to the half of sodium thiosulfate moles. So here S2O3 2 minus moles, we have to divide it by 2, that will equal to the iodine number of moles. So iodine number of moles here in our balance equation, this is our balance equation, the number of moles of iodine, here number of moles of iodine, we have to divide thiosulfate moles by 2. Okay, now the copper, number of copper moles will be equal to the amount of iodine, we have to multiply it by 2. So molar ratio of copper 2 plus 2, the stoichiometry of copper 2 plus 2 I2 mean 1:2. So we have to multiply number of moles of iodine by 2 to get the copper number of moles. As by using this procedure, you can calculate the concentration of copper as well as its number of moles, also its mass. So this is the procedure. I think procedure is clear for you. Now let's go to the our experimental area. We will do the titration. Carefully look at what I am doing and carefully look at the color changes. Let's go. Okay, let's identify what are the glass jars and apparatus I am using. Here I have my burette I have here 10 milliliter graduated pipette, I have pipette filler, white tile, distilled water. Here I have starch solution, starch. Here we are using starch as the indicator. I will show you how can I use that. Okay, my solutions. Here I have copper 2 plus solution. I have to find out its concentration. Here I have sodium thiosulfate solution. Okay. The concentration of this sodium thiosulfate solution is 0.01 m. So, it will be different in your lab. However, here concentration of this sodium thiosulfate solution is 0.01 m. By using this sodium thiosulfate, I will titrate our solution. Okay. After that, here I have 5 milliliters of potassium iodide. When I mix this potassium iodide and copper sulfate solution, copper 2 plus solution, I too will elaborate. Okay, that iodine will trap due to this excess potassium iodide, and that I will react with sodium thiosulfate. Okay, I will explain you every steps. Please remain with me and carefully look at what I am doing, what are the necessary steps. Okay, first of all I will rinse my, here already this burette washed and rinsed with distilled water. Now I will rinse it with small amount of sodium thiosulfate solution. I will add very small amount of sodium thiosulfate. I will rinse it with like that, this way, as I previously explained you. In horizontal position we have to rotate it like this. The solution will go through the one end to the other end, and after that I will wash the tap also. I will open the tap. At that time the solution will drain to the lower part. Okay. Now I will fill the burette with sodium thiosulfate solution. As usual, I have to use a funnel to fill out the burette. Okay. Okay. Now I will adjust the meniscus. Okay. Now it's very precise. Now it's 0. Now, okay. Now I have to pipette out this graduated pipette. I already wash with tap water, distilled water, and the solution, copper solution. I already rinse it with copper solution also. I will directly measure 10 milliliters of copper solution into this titration flask. Okay. Please carefully look at the techniques. I will drain. I will fill the pipette with 10 milliliters of copper solution. Okay. Now I will transfer this. This is the correct position. The pipette should be in vertical position. My conical flask or our titration flask or any vessel should be in an angle with respect to this vertical pipette. Okay, now everything drained. Okay, now here copper solution is alone. When I mix this potassium iodide with this copper solution, suddenly reaction will start. Copper 2 plus will reduce copper plus, this I minus will oxidize into I2. So there will be a color change. Come and look at very carefully. Come. Okay, now here you have we have our copper solution. It is very light blue color. When I add this potassium iodide into this copper solution, iodine will produce. Iodine is a gas, it will tend to evaporate. So I will use this wash glass and I will cover this conical flask, and the mixture I will keep 1 to 2 minutes to reaction to complete the reaction in a dark place. Okay, we will use our cupboards as a dark place. Okay, now I will show you what will happen after mixing this potassium iodide solution. Okay, now I added, you can see a sudden color change. It's yellow color, that means iodine is producing. So we have to close it by using this wash glass, and we will keep it inside a dark place 1 to 2 minutes until complete the reaction. Here I will use this cupboard. Okay, here I will close the door. I have to wait 2 minutes until complete the reactions. Okay. Okay, now 2 minutes is completed. I will take out the solution, and now I am going to titrate this solution with our 0.01 m sodium thiosulfate solution. Okay, there are so many color changes are here, so it's very important reaction. So we should not add our indicator first, we have to do titration. After some time we will add our indicator starch. So every steps are very important. Please come and look at very carefully. Come. Okay, here you can see the liberated iodine are trapped in the solution. It is somewhat brown color. So if we should not add our indicator, it is starch. Here we are using starch. You know, iodine and starch will produce blue color complex. Okay, when we add this starch into this solution, the iodine will react with starch molecules, the amylose and amylopectin molecules in this starch, and it will produce blue color complex. Okay. However, if we had initially the starch into this higher concentration of iodine solution, what will happen? The starch and iodine complex will be not dissociate back. So we can't observe any color change. So we have to lower the concentration of iodine. So we will titrate this iodine with sodium thiosulfate solution from our burette, and the iodine, when iodine concentration is low, the dark brown color of this solution will convert into pale yellow color, straw yellow or pale yellow color. At that time, at low concentration of iodine, we will add 1 or 2 drops of starch. At that time, with low concentration of iodine, that complex will be dissociate back. So it is easily dissociate. If not, if we had initially, that complex will not dissociate back. So we will do titration first with sodium thiosulfate until we get pale yellow color. Okay. Now see the color change. I am adding sodium thiosulfate. and the color will eventually pale yellow. Okay, here you can see I added around 5 milliliters of sodium thiosulfate. Now the color of the solution is somewhat yellow color. I will add another few drops of sodium thiosulfate. Now the color of the solution is getting decreasing. Now it is somewhat yellow color, but I will add further sodium thiosulfate. Now it is very pale yellow. That means this time it's very pale yellow. This time I will add my indicator. Now iodine concentration is very low in this solution. At that time I will add my indicator starch. Okay, you can see here I will add 1 to 2 drops of starch. Okay, when I adding starch, you can see the color change. Okay, now I added 2 drops. Now you can see the color is turned to blue color. Now the starch reacted with produced iodine and it formed a complex, the starch iodine complex. That complex is blue color. When I titrate this starch iodine complex with sodium thiosulfate, the complex is breaking down and the liberated I2 will react with our sodium thiosulfate. When the iodine is finished, the solution will be milk color. Okay, let's do that. Okay, now I am titrating with, you can see now I am titrating with drop by drop by my sodium thiosulfate solution, and now you can see the solution blue color lost. But the important thing is here, in starch structure there are some amylose and amylopectin structures. Some iodine molecules may trapped inside those amylopectin structures. So we have to release those trapped iodine. Okay, if we keep some time, the blue color will reappear. That means iodine will releasing from the starch iodine complex. Okay, now it's again colorless, but I am not sure. To make sure there is no any trapped iodine, I have to add 1 milliliter of potassium thiocyanate. At that time potassium thiocyanate, here I have potassium thiocyanate, I will add 1 milliliter of potassium thiocyanate. Potassium thiocyanate will react with starch iodine complex and it will release bound iodine. Now you can see again it turned to blue color. That means there are some trapped iodine molecules are there. So I will add again the sodium thiosulfate. I will titrate until it's we getting milky color solution. Okay, now you can see again the solution is colorless. Okay, I will add small amount of potassium thiocyanate again. If there are any trapped iodine molecules, they will release by this potassium thiocyanate. Okay, I added another milliliter, but now solution is milky color, not blue color. We will keep some time. If there are any iodine, the solution will be blue color, but here it's milky color. That means milky color means there is a precipitate, copper iodide precipitate produced here. Okay, now it's milky color. You can see that there is a precipitate inside of this titration flask. Now solution is milky color, mean there is no any blue color. That means reaction is end. Okay, now we can read the burette reading. Okay, by reading the burette reading, we can get the volume of sodium thiosulfate released. Okay, now it is you can see now 11.2. You can see it's 11.2. okay, volume is 11.2. Now we got the endpoint. You have to do this triplicates. Okay. Now we are in the conclusion part. I will explain every steps in this experiment what I did. Okay. First of all, I filled my burette with sodium thiosulfate solution with known concentration 0.01 m. Okay. In this titration flask, I added 10 milliliters of copper solution and I added 5 milliliters, that means excess amount of potassium iodide. What happened there? When I added 5 milliliters of excess potassium iodide, the copper 2 plus will reduce into Q plus ions, Cu plus, and I minus ions will oxidize into I2. Those I2 trapped in the solution because we added excess amount of potassium iodide. So I2 gas plus excess I minus will convert into I3 minus. So we titrated those I3 minus by using this sodium thiosulfate solution. Okay. So we can read the burette reading, but there are so many color changes. You saw that when we add potassium iodide into this copper solution, converted into its color converted into, initially it was colorless, it was converted into brown color or dark yellow color. That means iodine is liberated. Okay. I allowed 1 to 2 minutes, actually 2 minutes in a dark place until complete the reaction. After 2 minutes, I assumed the reaction is completed. Normally it needs 2 minutes to complete the reaction. So after complete the reaction, I start the titration, but initially I didn't add any indicator. Here we are using starch as the indicator. The important thing is when starch react with iodine, that means starch has two structures, amylose and amylopectin. Okay. So these amylopectins are coil structures. Iodine will goes to this coil and will produce a complex known as starch iodine complex, that is blue color. However, when there is high amount of iodine, higher concentration of iodine, the produced this starch iodine complex can't break again. It will not dissociate. It will be a permanent complex because iodine concentration is higher. So initially we didn't add the starch because the complex is permanent and we will not observe any color change further. Because of that, we started titration with sodium thiosulfate without adding indicator. After some time, the dark yellow color of the solution getting lower and lower, it decreasing, and after that it will convert into pale yellow solution. Pale yellow mean yellow color is reduced, that means iodine concentration is very low. At low concentration of iodine, the starch iodine complex can dissociate back. It is unstable complex. At that time we added 1 to 2 drops of starch. We could see blue color. Okay. That blue color indicate there is excess iodine. There are so many iodine molecules in the solution. So we will do our titration further. After some time, solution turn into clear solution. That means blue color disappeared. However, to confirm whether there are some iodine or not, we added 2% potassium thiocyanate, 1 milliliter. When we adding potassium thiocyanate, what will happen? The trapped iodine in the starch iodine complex will release and potassium thiocyanate molecules will go and bind to the starch and it will replace iodine sites. Okay, iodine will release, those iodine will give again a blue color. So we will do our titration again until the blue color convert into milky color. That means there is a precipitate in the solution, that is that's the copper iodide precipitate. Okay. However, now we can read the burette reading. By using burette reading, we know the amount of sodium thiosulfate. Okay. The number of moles of sodium thiosulfate we can compare with iodine. The stoichiometry of sodium thiosulfate and iodine is 2:1. Two sodium thiosulfate molecules will react with 1 iodine. So, number of moles of iodine can be calculated by using that relationship. So, number of moles of iodine should be equal to the half of sodium thiosulfate moles. So, but by using that relationship, we can calculate the initial copper solution's concentration and number of copper moles as well as its mass. So, that is the experiment. So, there are so many important steps we saw. I taught you very clearly. So, it is very interesting phenomena in chemistry, experiment in chemistry. So, please keep these things in your mind. Okay. Let's study another experiment in another video. Please subscribe my channel and share this with your friends, and please remain with me. I am Hasan Kalungarachi. Thank you and Iobowan.